To write an isotope notation for this atom, I first pay attention to number of protons in the nucleus, because that identifies what element it is. 6 protons, so it is carbon, symbol of carbon. At the left corner of the symbol of carbon, I will write atomic number of protons in the nucleus. In the upper left corner of the symbol, I will write mass number of protons and neutrons in the nucleus. 6 plus 6, 12. A different isotope of carbon here. 6 protons, so we are sure that it is carbon. However, it has an extra neutron in the nucleus, so it's slightly heavier. So we're putting the symbol of carbon to write an isotope notation. At the down left corner, atomic number 6 and 13 for the mass number at the top. And here is carbon with 8 neutrons in the nucleus. So symbol of carbon, atomic number 6, and mass number 6 plus 8, 14. Write an isotope notation for an atom with 26 protons and 30 neutrons. Element 26 on the periodic table is iron, symbol Fe. Number of protons, aka atomic number, at the bottom 26. Mass number, sum of protons and neutrons at the top. Write an isotope notation of the atom of barium 137, symbol of barium Ba. It is element number 56 on periodic table, so atomic number 56. Mass number for this isotope is given in its name, 137. Last one, 35 electrons and 45 neutrons. Number of electrons equal to the number of protons in an atom, so atomic number is 35, which is bromine. Mass number is 35 plus 45 equals 80. This is an atom of magnesium because I see 12 protons in the nucleus, and magnesium is element number 12 on the periodic table. What is its atomic number? 12. What is its mass number? 24. 12 protons plus 12 neutrons. 12 protons create positive 12 charge of the nucleus. 12 electrons create negative 12 charge outside of the nucleus. These charges cancel each other out. Net charge of the atom is 0. If magnesium will lose its 2 valence electrons, it will become an ion. Loss of electrons will make magnesium to gain charge of positive 2, because protons in the nucleus outnumber electrons. Element of aluminum has 13 protons in the nucleus because it is element number 13 on the periodic table. No protons outside of the nucleus. Atoms have an equal number of protons and electrons, so 13 electrons for aluminum. Electrons on the most outermost electron shell are called valence electrons. There are 3 of them in the atom of aluminum. If valence electrons are lost, the atom will become an ion with the net charge of positive 3. Element of sulfur has 16 protons in the nucleus because it is element number 16 on the periodic table. No neutrons outside of the nucleus. Atoms have an equal number of protons and electrons, so 16 electrons for sulfur. There are 6 valence electrons. If the atom of sulfur will gain 2 extra electrons, it will become an ion with the net charge of negative 2. Ion with 8 protons would be an ion of oxygen, mass number 17. Electrons outnumber protons by 2, so the net charge is negative 2. Aluminum has 13 protons. To have a charge of positive 3, it must be 3 electrons short of the number of protons, so 10 electrons. Ion with 15 protons would be phosphorus, mass number 31. Electrons outnumber protons by 3, so the net charge is negative 3. Atoms lose or gain electrons to achieve complete valence shell. When it holds the maximum number of electrons, that makes them stable. For majority of elements, that means getting 8 electrons on the most outer shell. Fluorine is 1 electron short from the having full octet, 8 electrons on the valence shell. It will steal 1 electron to become an ion with a charge of negative 1. Phosphorus is 3 electrons short of having a full octet. It will steal 3 electrons to add them to its valence shell and become an ion with a charge of negative 3. Magnesium is 6 electrons short from the full octet, but stealing 6 electrons requires too much energy, so magnesium is much more likely to lose 2 valence electrons and become an ion with a charge of positive 2. Underneath there is a full octet. Potassium is 7 electrons short from the full octet. If it loses 1 electron, it will have a full octet underneath, and it will become an ion with a charge of positive 1. Atoms gain or lose electrons to become more stable as ions. For majority of the elements, the end goal is to have a full octet, 8 electrons on the most outer shell. But for small atoms such as lithium, beryllium, boron, stability can be achieved through getting down to having only first electron shell and having 2 electrons on it. The first shell is complete when it holds 2 electrons, making those ions more stable. Considering that having full valence shell is the way to become stable, the most stable and consequently unreactive elements are the ones that already have that. Noble gases are called so for their unreactive nature, which comes from the fact that they already have the full octet on valence shell, or in case of the helium, a full duo.